Okay, so I'm gonna be showing you how to do three-phase circuits. So the question asks for the following circuit: ZL 7 plus 14J and ZT is 15 minus 9J. So the first thing we're gonna have to know is this configuration over here is in the delta form, and this configuration over here is in the Y form. And after that, so the very first step we're gonna do is we're gonna determine the sequence, whether it's negative or positive. And so we're going to determine the sequence of the delta form, and the way we do that is we look at the pattern. If it's 0, negative 120, and negative 120, it's going to be in the positive sequence. 0, negative 120, 120 is going to be in the negative sequence. So we look over here. It says 0, 120, negative 120. We go back, 0, negative 120, 120. It's going to be negative sequence. So let's write it down. So 1A, it's going to be negative sequence. Cool. Alright, secondly, we're going to convert any delta to Y form. So this is in the delta configuration. We want to get it into the Y configuration, and that's how it's going to look. And the way we do that is, let's forget about the drawing. There's a formula we have to know, and that formula is delta Vy is equal to delta Vn, sorry, not Vn, my bad, just delta V. So the Y configuration is equal to the delta configuration divided by root 3 angle 30. This is the phase. So let's start plugging in our values. We know that our delta V, so we're going to be finding, this is just what the notation I use. Delta V AN is equal to delta V AB. VAB is, let's look over here, is from A to B, and we know our value from A to B is 35 at angle 30. So we'll just write this whole thing down. 30. So then we just plug in our values. Blah blah blah. Which is, what did we say it was? 35 angle 0 divided by root 3